Alright, so let's now move to creating matrices. So we've seen how to create vectors, we've seen the different types of vectors and a few ways of creating vectors. Now, matrices. So a matrix, as I said, a vector is a matrix, but matrices are beyond just one dimension. They can be two-dimensional and even three-dimensional. Actually, the dimensions, there's no limit to the number of dimensions you can have, but commonly you just have two dimensions. Most commonly, you have two dimensions. So this is a two-dimensional matrix, two rows and two columns. 2 by 2 matrix because it has two rows and has two columns. This is a 2 by 3 matrix containing two rows and three columns. This is 2 by 2, this is 2 by 2, this is 3 by 3. So note here that a matrix consists of two rows. In each of these two rows, there are two elements. So one way you could look at it is each row has two columns. Each row has two columns. So the entire matrix has two columns. Each row has two columns, the entire matrix has two columns. Okay. Here each row has three columns, the entire matrix has three columns. There's no matrix that has an uneven number of columns. Right? So each row in the matrix must have the same number of elements or columns. Right, so we'll be creating a matrix in MATLAB in a similar way. We'll just create two rows. For instance, the 2 by 2 matrix. Create the 2 by 2 matrix by enclosing in square brackets two rows that each have the same number of elements. And then the most important part is how we will separate the two rows. So if we have this matrix 3, 4, 5, 6, 3, so we're creating a row vector 5, 6. So the separator here between the two rows will be a semicolon. Telling MATLAB that hey, take everything after the semicolon to the next line, to the next row. So this here now is a divider between the two rows. The first row will contain this, second row will contain this. So you have two row vectors separated on different placed on different rows. So if you press this, this is now, why is it taking 3, 4, 5, 6. First row and the second row. Like 3, 4, semicolon, 5, 6. So we can also do this and extend this matrix. So 7, 8, that's another row. 9, 10, that's another row. And to be extended down all the way, right? Because we're putting in the same number of elements in each row, or the same number of columns in each row, so that we will have it that the entire matrix would have just as many columns as there are elements in each row. Right? So it would be wrong for us to create any one of the rows having more or less elements than the other rows. So if we do this, if we make it so that the last row has 3 elements rather than 2, we'll have an error because the dimensions will be mismatched. The dimensions are not consistent, so there must be consistency in the number of rows, in the number of elements, sorry, in each row, so that the entire matrix would have same number of columns as there are elements in each row. Okay, so you can't have 2 here, 2 here, 2 here, and then 3 down here. Right. So let's create another one. Let's create a 2 by 3 matrix, semicolon. Right. Let's create a 3 by 3 matrix. Right. So there are some special special matrices in matrix mathematics. So one is called the zeros matrix. Zeros matrix is filled with all zeros, so it's just zeros in every single position in the matrix. The ones matrix, just this but filled with ones. The identity matrix. With the identity matrix is always a square matrix. Square meaning the number of rows is equal to the number of columns. Identity matrix is always a square matrix, wherein the diagonal is filled with ones and all other positions are filled with zeros. So if it was a 2 by 2 matrix, but it was a 2 by 2 matrix, this one and this one would be ones, here and here would be zeros. If it was a 4 by 4 matrix, you'd have ones all along the diagonal and every other position would be zero. So that's the identity matrix. It only has ones along the diagonal. So let's try. There are special functions that are used for creating these special matrices in MATLAB. So one function for creating zeros is the zero matrix is zeros. So a way of calling it, so you can pass in a single number, and this single number would be the dimensions, the number of rows and the number of columns of that zero matrix. So let's try it. Zeros. This will create a 3 by 3 matrix filled with zeros. Zeros. 1 by 1 matrix. Right. 1 by 1 matrix and a 2 by 2 matrix. Next, another way of calling it is by specifying the size. So that would be the dimensions. So you start with the rows and then the columns. So if I pass in one row, 6 columns, this would be 1 by 6 matrix or a row vector containing 6 zeros. If I do it 2 by 4, 2 by 4 zero matrix, 6 4 6 by 4 zero matrix. So that's for zeros. And for creating ones, syntax is similar. The function is O and ES ones. So if I pass in 4, give me a 4 by 4 matrix containing all ones. I pass in 3 by 3 matrix containing all ones, and I can specify the size dimensions of the matrix as I want it. 3 by 5, 3 by 1, 2 by 4. Like, however you want to, just specify the rows and the columns need to be, the matrix return will be filled with ones. Then lastly, for the identity matrix, remember the identity matrix consists of ones just along the diagonal and every other position is filled with zeros. So for the identity matrix, the name of the function is I. So I here returns an identity matrix. Yep. So you can pass in, just the syntax is very similar to for zeros and ones. So I 2 by 2 identity matrix, I 3. So you notice the diagonals are filled with ones. I 10. Same thing, right? Then one last special function is magic. So what magic does is it returns a magic square. So it's always a square matrix. What's a magic square? A magic square, an n by n matrix constructed from the integers 1 through n2, n2 being that's the number you pass into, with equal row and column sums. Equal row and column sums. Let me explain what it means. So if I pass in magic 3, so it's going to give me a 3 by 3 matrix. And if you end up calculating the sum of the numbers along each row, in each row, you get the same number. If you calculate the sum of numbers in each column, you get the same number. So that's what the magic function does. So let's just return an answer, and you'll see. So this is 816357492. If you add up all these numbers, this is 15. Add these ones up, you get 15. Add these up, you get 15. That's along the columns. And along the rows, do the same thing. 816 is 8 plus 7, which is 15. 8 plus 7, which is 15. Then 13 plus 7 to 2, which is also 15. So along the rows and along the columns, the sum is always the same. So it says equal row and column sums. That's what the magic function does. And all you need to do is pass in the dimensions of the square function. Magic 5. So the same thing here. Add these up, add these up, add these up, add these up, add these up. Their sums will always be the same, and so with the rows. So here in this case, I can't do it quickly in my mind. This is 22. This is also 22. 44. 44 plus 21 is 65. So 65 here, you also get 65 here, 65, 65, 65. This is 65, 22, 22, yes, 65. Alright. So that's the zeros, ones, I and magic, which are special functions for creating matrices. And we've also seen how to create matrices manually. All you need to do is create the different rows and separate them with the semicolon.